this is my basic drawing. So it's going to start with a signal from the brain. It's going to travel down the dendrites. I'm also going to be drawing in blue, so just, you know. Once it does that, the vesicles are going to be turned inside out, which is then going to dump acetylcholine. Once the acetylcholine is dumped, it's going to bind to these receptors right there where the little circles are. As it does that, the acetylcholine acts as a key that unlocks the door, which is then going to bring in sodium into the muscle membrane. Sodium is then going to make the muscle somewhat negative, depolarize it. This is going to cause an action potential. The action potential is going to travel down the T tubules. That's then going to activate the sarcoplasmic reticulum. Once it does that, calcium is then going to be released to the actin and myosin filaments. The calcium is going to bind to troponin, which is those dots there, right? That's going to shift tropomyosin, which is then going to allow these little active sites to appear. The active sites are what is going to bind to the myosin head. We just connect the dots right there. Once that happens, that's going to kick out inorganic phosphate. It's going to kick off ADP, and ATP is going to kick the head off. The contraction can continue to occur if there's more ADP and ATP within the calcium binding.